Okay, we're in our second video of 11.2 talking about permutations. Let's start off with this kind of scenario, and then we're going to talk about if we can come up with a formula to help us figure out how to solve permutations without having to write it all out. So it says here you're a Little League coach with 13 players on your team. You need to pick a lineup with 9 players. And order matters, right? In baseball, don't you have certain players go first, second, third, last, and so on? So order matters. And because order matters, we know that this is going to be a permutation. When we can rearrange things and order makes a difference, we call that a permutation. I have 13 players. I want to pick 9 of them. How many different batting orders could we possibly form? Well, again, it always helps me kind of visualize what's going on. I know that I want to pick 9 players, so I have my 9 little spots. When I go to pick the first player, how many players do I have to choose from? Well, doesn't it say that I have 13 players on my team? So I actually have 13 players that I can choose from to put in that one spot. I'm going to pick one player, but I have 13 to choose from the first time. How many players do I have the second time I have to pick in that second spot? Well, since I've already picked a player, aren't I down to 12 different players, 12 different options? And then I have 11, and I have 10, and 9, and 8, and 7, and 6, and 5, right? And then I can multiply all of these together to figure out how many different lineups I could possibly make. I don't have my calculator next to me, but you can go ahead and multiply those and figure out that you have a lot of different ways to pick 9 kids from a team of 13. That's a hard decision. Now, what happens if those numbers get bigger? Let's say you had 13,000 employees for your business and you wanted to pick 792 to go on a conference. You wouldn't want to do 792 little spots on your paper. So is there a formula, a way that we can set these problems up a little bit faster and easier, more efficiently when the numbers get bigger and bigger and bigger? Well, there is. There is a formula for permutations. It looks like this. We have a P to let us know that we're using a permutation. There's a little subscript of an N and an R, where the N means how many we have to choose from, and the R means how many we want. So in our Little League example, it's a permutation. We know the order matters. We have 13 kids on our baseball team, and we want to pick 9 of them. So that would be our setup. The formula then says that we're going to do our N factorial. So in this case, it would be our 13 factorial. On the bottom, we have an N minus R factorial. Our N was 13, our R was 9, and then we want to take the factorial of that number. So if we were simplifying this a little bit, we have a 13 factorial on the top, and we have a 4 factorial on the bottom. Just like our example from the last video, can we say 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial? And then can I actually stop there because I know that the 4, the 3, the 2, the 1 are going to reduce each other. And I'm left with 13, 12, 11, 10, 9, 8, 7, 6, 5, and I can multiply all those together, which is what we had up above, right? But we can use this formula now to set up different examples where the numbers might be a little bit bigger. Look at example 4 with me. It says here you and 19 of your friends have decided to form a business. The group needs to choose 3 officers, a CEO, an operating manager, and a treasurer. And how many different ways can these offices be filled? Well, order matters in this case because somebody could be the CEO or they could have a different job requirement. Maybe they're the treasurer. And because I can rearrange those different jobs, order matters. It makes a difference. So we know that this is a permutation. Permutation. We know how many people do we have total. Now be careful. It says you and 19 of your friends. So isn't that really 20 people total? So be careful with that one. And how many people are we going to choose? Well, we're going to choose 3, right? The CEO, the operating manager, and the treasurer. So now I have a formula that says 20, choose 3. We're using our permutation. We have 20 people. We want to choose 3 from the group. All right, let's set up that permutation formula. We have our 20 factorial on top. We have our 20 minus 3 factorial on the bottom. We can simplify a little bit and say that we have a 20 factorial divided by 17 factorial. Let's write it all out. We have a 20, 19, 18, 17, and I can stop there, right? Because the 17 factorial in the numerator and denominator can reduce each other. And so then all we have to do is figure out what 20 times 19 times 18 is. If you have 20 people and you want to choose 3 for different offices, you have 6,840 different ways you can rearrange and pick 3 out of the 20 using our permutation formula. All right, let's look at this last one here. Example number 5. It says how many different programming schedules can be arranged by choosing 5 sitcom comedies from a collection of 9 classic sitcoms. And so we have to think carefully on this one about if order matters. And so on this one, we could put one TV show first versus second versus third. And so order matters in this particular example. And so we know that this is, again, a permutation problem. Okay, how many different TV shows do we have to choose from? 9. And how many are we going to choose out of those 9? 5, right? And so your setup should look like mine. And I'd like you to pause the video. I'd like you to use your permutation formula, simplify it all the way down, and tell me how many different ways can you choose 5 of these shows out of the 9. All right, I have 9 factorial over 9 minus 5 factorial. I have 9 factorial divided by 4 factorial. I have 9, 8, 7, 6, 5 because the 4 factorial on the top and the 4 factorial on the bottom reduce. And did you end up getting 15,120 different ways you can pick 5 shows if you have 9 sitcoms to choose from? All right, make sure that you practice that permutation formula, maybe making sure that you write it on your note card so you remember, because we're going to add to it a little bit in the next video.